Hello, I'm Patrick Roach from Inedo. Thank you all for attending. We will be recording this webinar, and to ensure audio quality, all attendees will be muted. Today, we'll be discussing vulnerability scanning and management as part of your DevOps toolchain, focusing on the ProGet Vör Security integration. Here with me today is Ken Duck, the founder and CEO of Vör Security. Ken will be presenting today on the impact vulnerabilities have on software development and why assessment of known vulnerabilities is important, as well as providing a quick demo on how to scan and manage vulnerabilities in ProGet. We'll end the webinar with a Q&A session. If you have questions during the webinar, simply use the questions toolbar from GoToWebinar. Thank you. At this point, I'm going to hand it over to Ken.
Good afternoon. As mentioned, my name is Ken Duck from Vör Security. Very few people develop their software in isolation. Almost every application depends on third-party libraries and software. But when you use someone else's code, you also get someone else's problems. A recent survey indicates that open-source software components are used in over 95% of business-critical applications. It seems likely that every non-trivial application uses third-party components, be they open-source or commercial. Bear in mind, this could mean libraries, compilers, or necessary infrastructure. In a typical application, these components make up a surprising percentage of the functionality. Using third-party libraries greatly decreases your time to market, can be significantly less expensive, and if you choose the right components, can reduce the number of bugs in your software. But no software is completely bug-free, and many libraries have security vulnerabilities. If you use these libraries, then your software is itself vulnerable. If your software is delivered with vulnerabilities, then it might be exploited and become the source of a breach. Both open source and commercial components suffer from vulnerabilities. One of the most publicized vulnerabilities to date is the Heartbleed vulnerability found in OpenSSL, a popular cryptography library used in a large number of applications, not the least of which are a significant number of deployed web servers. On its discovery, over 500,000 websites were vulnerable to Heartbleed-based attacks. And yet, 2 years later, there were still over 224,000 vulnerable Internet-connected systems. Though some of these are vulnerable web servers, many are other affected software which still use the vulnerable library. It's possible that some of these devices either cannot be upgraded or people traditionally do not tend to upgrade, which is a problem in its own right. And here we are, almost 3 years later, and there are still over 199,000 vulnerable Internet-connected systems. Now, this number only reflects services that were connected to the Internet during the scan and would not include intranet and sporadically connected software. How many of these vulnerable services are active applications, vulnerable because the companies are not aware that they're vulnerable? Remember that we're not just talking about web servers. This is a very small selection of the software and a few sites affected by Heartbleed. Companies and developers might not realize that their dependencies themselves depend on vulnerable versions of these and other software. Consider, too, that Heartbleed was extremely well publicized. The majority of vulnerabilities are discovered and fixed in relative quiet. How many of those still lurk in software for months or years after they're discovered? Well, let's consider a 2016 report by Black Duck Software on the state of open source security in commercial applications. There were some very interesting and surprising findings. The report was produced by analyzing over 200 applications that were previously audited by the code owners. It was found that on average, the commercial applications which were intended for release to users contained over 100 unique open source components and make up for 35% of the application. This percentage is often higher for internal tools. Even commercial third-party packages often include open source components, just as open source components depend on other open source libraries. For this reason, a company's use of third-party dependencies is often much higher than they expect. Now, I've been previously engaged as a software auditor and as part of the job produce a list of dependencies which is compared with the company's own list. In over 7 years, not once did these lists match. Now, in the applications considered for the report, there were several interesting statistics, including, on average, there were 5 vulnerable components per application, with a total of 22 individual vulnerabilities, since components often suffer from multiple vulnerabilities. The vulnerabilities discovered were often not new, but had an average age of 5 years. Now, this last number is particularly disturbing when one considers that for all vulnerabilities that are eventually exploited, 99.9% of those are compromised within the first year after discovery, which means it is very likely these products contain vulnerabilities with already known exploits. Now let's tie this in with the previous discussion on Heartbleed. There are 199,000 known affected Internet-connected applications and an unknown number of intranet-facing and other vulnerable applications. Of the over 200 applications audited for the report, over 10% were still affected by Heartbleed. These are companies that self-audited their software before submitting it for auditing by a third party and were therefore not aware that they were vulnerable. It seems quite possible that a reasonable number of these 199,000 plus services are vulnerable for the same reason. The developers don't realize that they're vulnerable. Almost 10% of these 200 applications audited were vulnerable to Poodle, another reasonably well-known issue, and a further 5% were affected by Logjam and Freak. These vulnerabilities were all publicized widely enough to get their own names. Many do not, most do not. And this is why you should be concerned about vulnerabilities in your dependencies, because software is so easily, unwittingly vulnerable. Of course, you're here because vulnerabilities are a concern, and you want to protect yourself from using vulnerable dependencies. This can be done through careful research. The information is out there. It's in issue trackers, advisories, public vulnerability databases, blogs, and other web sources. You can monitor these sources and be well informed when new problems are found. As your component dependency count increases, this job can quickly become cumbersome and requires continual effort to maintain. You can instead use a vulnerability feed to aggregate this information for you. Using a vulnerability feed with ProGet, you can collect and report only those vulnerabilities that affect your dependencies, allowing you to focus instead on assessment and development. ProGet provides easy-to-use vulnerability assessment and package management that will allow you to easily and quickly ensure that vulnerable dependencies do not remain or even make it into your final product. To demonstrate these capabilities, we will be using the VorSecurity vulnerability feed. First, we need to set up the VorSecurity vulnerability source in ProGet. Now, this page lists the steps that are required, but we're about to visit these steps one by one. Prior to setting up the feed, you need an account at Vör Security. So you go to VorSecurity.com, and then you click the Login Profile button. If you don't have an account, registering is quick and easy, requiring only an email address. Once you have an account, you log in with your credentials. Right now, you can request a trial license. The professional license link will be enabled within the week. Make special note of your API token, which you can see down here at the bottom. Your email address and API token are all that are required to enable your vulnerability source in ProGet. And here's ProGet. Now, first thing we'll do here now is we'll set up the vulnerability source. To do that, you go to the admin page by clicking on the gear at the top right. And then you go and you select Manage Vulnerability Sources. As you can see, I've already created a vulnerability source. Now to do that, I followed these steps. You click on Create Vulnerability Source, select VorSecurity, put in your email address and the API key, the security token, from the VorSecurity page, and you click Save. It's as easy as that. Now we're going to add the vulnerability source to your feed. Now to do that, you click on the feeds link at the top. This gives me a list of all my different feeds. And I'm going to select the appropriate feed. In this case, I want to add it to my NuGet production feed. I select there, click on Manage Feed. You locate the vulnerability sources select section, which is down here. You'll see there's no vulnerability sources yet. I will click Add Source. Select the VorSecurity source and click Add. Now you should see right here, you should see the newly added source in the vulnerability sources table. When you first add it, you will see 0 known vulnerabilities. I have used this source before. I have several different feeds. There are already some known vulnerabilities. Now the vulnerability sources are by default checked for vulnerabilities once a day, but there's no need for us to wait. We can force a run at any time. And that's what we're going to do now. So first, I'm going to go to the admin page again and scroll down and see scheduled tasks. If I scroll to the bottom here, I can see the vulnerability downloader, which you can see is scheduled to run automatically every day between 2 a.m. and 7 a.m., sometime in there. Now to force a run automatically, you just click this play button, and then you hit Yes, Run Task. Now this should open a new page that shows progress, but sometimes that doesn't happen like it did here. If that happens, you simply click it again, click Yes, and it will open this time, and we can see the progress running, the process running. Now we're going to watch as it's retrieved. Now this should take no more than a couple of minutes, depending on the number of your dependencies and server availability. New vulnerabilities are discovered. There you go, it's already finished in this case. New vulnerabilities are discovered all the time, and VorSecurity is continually on the lookout. ProGet downloads vulnerabilities every day, ensuring that you're up to date. It's important to note that currently vulnerabilities are only checked for local packages. Also note that checking is not real-time. If you add a new package in your project, it is not immediately checked for vulnerabilities. It must first be added to ProGet's local packages, and then the vulnerability downloader must be run, either manually as we did now or automatically. VorSecurity uses both manual and automatic processes to find new vulnerabilities. There are tens or hundreds of thousands of packages with untold issues. One of the benefits of the professional license is that your packages are promoted towards the top of the research queue, and this ensures that we're always looking to make sure that your dependencies are up to date. Now that your vulnerabilities are updated, it's time to assess the findings and determine the appropriate actions. But before you do that, before you assess any vulnerabilities, you might want to manage the assessment types. Click on the admin button, and on the left-hand side, you select Manage Assessment Types. As you can see, there are a few built-in types. You might want to add a new type with which to tag vulnerabilities that are not a concern at all, and that you don't want to revisit, that don't have an expiration. This can be dangerous if your software functionality changes and starts using the vulnerable functionality, so it should be used with caution. The benefit of the 90-day expiration is it allows you to ensure that vulnerabilities have not become pertinent in the meanwhile. There may also be vulnerabilities which you want to block and do not wish to reassess every 90 or however many days. You just want to permanently block these. Or perhaps your reviews happen more or less often. You can change existing or add new assessment types to match your procedures. I'm going to add a new assessment type by first clicking the Create button and putting in a name. I don't want this one to expire, and I'm going to select a severity. In this case, I'm just going to select the error severity, and I want this to block downloads. I click Save, and I now have my new vulnerability type. Once you've set up the assessment types to your satisfaction, you can proceed. To view the complete set of identified vulnerabilities, you click on the Vulnerabilities link at the top. You can see a bunch of them here. I'm going to explore one of these vulnerabilities. Each vulnerability has a title and a brief description, as well as a version or a version range. You can see, for example, that this vulnerability affects AngularJS, any version prior to 1.4.10. The references that are provided here provide supporting evidence for the identification of the vulnerability. Depending on the vulnerability, this can provide more detailed descriptions, version information, possible mitigations, and even the vulnerable code itself. For example, this top link here takes you to the fix, the code that was both removed and added in order to repair this vulnerability. Once you're satisfied with this information, you can assess the vulnerability, which I do by clicking this button, the Assess button. The type you'll assign to a vulnerability depends on your particular needs. You might decide for expediency that vulnerabilities that affect old versions do not require in-depth study and should just be set to blocking. You might assess all vulnerabilities as blocking and always upgrade to a newer version of the software if it exists. But this might be too dangerous an approach, since new versions might introduce instability, or it's possible a release of your software might be imminent, making library changes difficult. Deeper understanding and analysis of the vulnerability could allow you to provide mitigations in your own code and avoid upgrading. Or it's possible that there are no possible upgrades on the software you're using and you need to provide a mitigation instead. Now in this case, I'm just going to mark this one as critical and click Save. Now let's visit a package for which we have blocking vulnerabilities. I'm going to click on Packages. And we just added this one. We made this one blocking. On the left, you can see that the download of this package is blocked. This holds true not only for the web UI, but for any applicable tools. In this case, for example, NuGet and Visual Studio will be blocked from using this version of this particular package. So long as your builds are always run clean and pull their dependencies from ProGet local packages, you can be sure that they do not contain blocking vulnerabilities, since those downloads will be blocked. Now at this point, we've seen how to add vulnerability sources, retrieve vulnerabilities, and perform assessments. How can this functionality be used to protect a release build? Now currently, my preferred method is to have a development feed and a production feed. NuGet development, this one here, which I'll just click on Manage, NuGet development is backed by the desired feed connectors, in this case the official NuGet repository. Doing this allows developers to add packages as required whenever they need them without needing intervention by the production build team. The production feed, on the other hand, does not have a feed connector. It is instead fed by promoting specific packages. For example, let's just go back to some of my development packages here. I might decide that I want the libuv package in my production feed. Now you'll note it has no blocking vulnerabilities currently. So I just click on the promotions link, followed by the promote package button. And I'll click promote. You can put in some comments explaining why. Click promote. I'll navigate to the production feed again here, so you can see that the package has been added. I use the production feed in my release build environment. My release build will fail if a required package is not in the feed, so I can ensure that only audited packages make it into my release. Now, it's impossible to defend against a threat that you don't know exists, so you need a vulnerability policy and process. Now, first, you need to consider your existing practices. You don't want a vulnerability management to become a burden, but you also don't want it to be skipped, so introduce it in a manner that best suits your current environment. Second, make vulnerability management an ongoing process. It should not just be fire and forget. New vulnerabilities are discovered daily. Third, fully understand the security risks and prioritize your efforts. Some vulnerabilities require immediate action, while others have non-critical impact or are extremely difficult to exploit. And finally, monitor both in development and released products. The sooner you catch a vulnerability in your development process, the cheaper it is to resolve. But you also don't want your existing customers to be left on their own. Now, where do you go from here? Managing packages and vulnerabilities are an important tool in the overarching security development lifecycle. These are secure practices that should be followed throughout your development process. Security should be considered all the way from requirements collection and design through development and verification, all the way to developing and following through with a plan for responding to vulnerabilities in released products. You want to make secure development part of your process and not just a checkbox. And that concludes the demonstration. Thank you.
Ken, right off the bat, our first question is from Graham. And Graham is concerned that his build dev environment has limited internet connectivity. Can only access whitelisted hosts. What hosts or ports does VorSecurity tool need to connect to, or is it just an HTTPS poll to an external server?
Yes, so ProGet downloads the information, yes, just through an HTTPS secure connection with the VorSecurity servers.
Excellent. The next question comes from Mike, and Mike wants to know where Vor gets its vulnerability data from.
Okay, so VorSecurity scans several different locations for its data. There are several vulnerability databases. Some of them are actually completely open and free. You might have heard of the National Vulnerability Database. We get several vulnerabilities from there. But we also perform scanning for open source products in particular, we perform scanning of the issue tracking systems. For instance, on GitHub projects, we have the GitHub issue tracking system. So we scan those looking for vulnerabilities as well. We also track various mailing lists and blogs and other online resources that tell you about vulnerabilities. So we're always looking for new blogs, new mailing lists, advisory lists, for instance, Microsoft advisories that come up. So we're always looking for new ones that we can pull into our database, and it's all aggregated into the one place.
Okay, Anne would like to know what repositories or feed types are supported.
Yes, okay, good. So currently we support, I guess there's NuGet support, Bower, NPM. We've got, if you have chocolatey packages, we do chocolatey as well, and we do Maven. Now there are several others that are in the pipeline that are coming along even as we speak. We've got, I'm going to have to check in on that, sorry. But we do have several others that are in process. I know there's Python, example, is one that's coming pipeline as well, and PHP, Composer packages specifically.
Excellent. Graham has another question, actually. If you have packages that have vulnerabilities marked as warning, not blocked, when are those warnings shown?
Those warnings, now that's a good question. I might have to dig a little deeper on that, but so far as my use of the tool has been showing, that just shows the warnings show when you're looking at the vulnerability list itself. Now that vulnerability list you can tune down so that you're looking at just vulnerabilities for specific packages, so you don't need to scan through the entire thing. You can just look at the filtered list and see the ones for particular, for instance, all your NuGet vulnerabilities or your NuGet libuv vulnerabilities. So you can focus it down. But I've seen them so far just in that particular view.
Great. Let's see. James would like to know, can the Vör Security integration be configured to run offline? Or do you need an active internet access, excuse me?
At this time, it does require an internet connection. The database is remotely supported. So at least during the fetching phase. So let me back that up a bit. It's just, of course, during the vulnerability download phase. So you could, for example, if you had a connection that you could put up every week or so, then you could do a download just during that time. But the download does have to happen online at this time, at this moment.
And here's one that looks like actually it's targeted for me. It's what edition of ProGet is required for the Vör integration to work with. And to that, it's any paid version. That's the basic, load balanced, and enterprise. Also, any enterprise trials and any backdated versions starting at 4.6. All right. Well, first, I want to thank Ken for presenting today. So thank you very much, Ken.
Thank you.
I want to thank everybody else for joining us as well today. If you are looking to try out vulnerability scanning firsthand, you can download the latest version of ProGet to get started, and then of course you have to request a trial from VorSecurity. Thank you very much once again,